Welcome to Spring LIB.
This is the answer to chapter 30, number 38 from the Smith Organic Chemistry textbook. And we are asked to treat cholesterol with several different reagents and predict what the products will be. And so I've drawn cholesterol here at the top of the screen. And I'm going to avoid redrawing it as often as possible. For a couple of these answers, I am going to redraw the entire molecule essentially when the reaction takes place at the double bond here, I'm going to redraw the entire molecule for the answer. But otherwise, these reactions are going to take place at the alcohol here. And so these are really the only two functional groups in this molecule. And so even if you don't necessarily remember how all of these reagents work, you should be able to identify that the only functional groups in this molecule are that alcohol and that double bond. And therefore, whatever is going to happen is going to happen at one of those two positions. And so when we look at A, we're going to be treating an alcohol with an acid chloride. And so what I'm actually going to do is do this like that, and then just to show, so that squiggle means that the entire rest of the molecule is over there. But there's no sense in redrawing the entire rest of the molecule because nothing else is happening. All the reaction here is taking place at this alcohol. And so what is going to happen is we're going to form an ester. If you remember from the carboxylic acid and carboxylic acid derivatives chapter, treatment of an alcohol with an acid chloride, the alcohol is going to do a nucleophilic attack on the acid chloride. The chlorine will get kicked out, tetrahedral intermediate, and then the chlorine will actually get kicked out when the oxygen closes back down to reform the carbonyl. So here's our product for A. We're just forming the acetate. And so for B, unfortunately, this is going to be one of the two where I am going to redraw the entire molecule. And so here is our tetracyclic ring system. 3 fused rings, 4th fused ring. And so remember, hydrogen gas and palladium on carbon is going to hydrogenate a double bond. And so nothing else in this molecule is going to be affected. So hydrogen, the other methyl group, another hydrogen, and then our chain here, methyl group, hydrogen, 2, 4. Okay, and so the reactivity here took place at the double bond. So we have 2 new hydrogens here and here that were not there in the starting cholesterol. And so that's the answer to B. So for C, again, we can safely just do this. Oh, so actually we can't even do that. So C is PCC, pyridinium chlorochromate. And we should remember that PCC oxidizes an alcohol up to the corresponding carbonyl. So this is a secondary alcohol. So it's going to oxidize the secondary alcohol up to a ketone. And so again, we can draw a squiggle to indicate that the rest of the molecule is unchanged. And the entire reaction here for C is that this alcohol has been oxidized to a ketone. So that's C. So then for D, again, we can just draw the alcohol, just this portion of the molecule. We'll do that, and then squiggle. So the rest of the molecule is unchanged. And what we're doing here is treating an alcohol with a acid and some acid. And so that's going to be a Fischer esterification. And so be an ester. And when we're told that it's oleic acid, so we should remember oleic acid is going to be 7 CH2s and then a double bond. Oops, pardon me. So I'm actually going to move this over so that I don't run out of room. So 7 CH2s, C double bond C, and then 7 more CH2s, and then a CH3. So there we go. We've just made the Fischer ester, or you wouldn't really call it that. You just call it an ester. We've made the ester of oleic acid and this alcohol by Fischer esterification. And so that's D. And then for E, we have a hydroboration oxidation. And so I am going to redraw the entire molecule for this answer as well. We have plenty of space on this page. So I'm just going to draw it down here. So remember, for this answer as well, the double bond is the only portion of this molecule that's going to be affected by hydroboration oxidation. There's our third ring. Oof. There's our 5-membered ring. So we can go ahead and put our alcohol here. The alcohol is not going to be affected. And we can go ahead and draw in everything else that we're given to start the molecule with. So hydrogen here, hydrogen here, hydrogen here, another methyl group here, and then this side chain. 1, 2, 3, 4. Okay, and so remember in the starting cholesterol, we had a double bond here. So that double bond is what's going to be affected by hydroboration oxidation. And so we're going to add an alcohol there and a proton with the same stereochemistry. And so, yes, so nothing else in the molecule is affected. Oops, and it looks like just forget to include a hydrogen there. All right, so nothing else in the molecule is affected. The hydroboration oxidation acts only on the double bond. And so this is the answer to part E of this question. And overall, this was the answer to chapter 30, problem number 38.